Hello, in this video we're going to look at the unit circle and circular functions. Now, when we consider the unit circle, the first thing in which that you will have to look at is the equation. So like x squared plus y squared equals to 1. Now, we can draw, like for example, the circle with radius 1. Now, in this case, like of course, like you have that the radius would have to be 1, so this is -1, that's 1, and that's 1, and that's -1. Now, the other thing of which that we know is that, we can project a ray as it intersects with our unit circle. And, yeah, this circle is not perfect, but we'll just go ahead and, use this one. So we have that this is theta. Now, this ordered pair right there along the circle is the ordered pair x comma y. But the question becomes, like what specific coordinate this might be relative to the angle that we have over here that we call theta. Now, in order to figure that out, basically you would have to refer to the equation for the length of the arc. So we know that the length of the arc is equal to r times theta. But here, notice that the value for r is actually going to be 1. So we have that means that s is actually equal to theta. Okay, well that's kind of interesting. So where this leads us is that the thing of which that we do know by definition is that cosine of theta is equal to x over r. But notice that this is going to tell us that x is equal to cosine of theta. But notice that theta is s, so that's just going to be cosine of s. Okay, that's kind of interesting. So that tells us furthermore that if we look at sine theta, it's y over r. But again, remember how like r is equal to 1. So basically this tells us similarly that y is equal to sine of s. So all that means basically is that the ordered pair x comma y is also the same thing as cosine of s comma sine of s. Now you can replace this with thetas if you want to, which mostly, like if you look at a formula sheet, most of the time it'll say cosine of theta versus cosine of s. Now keep in mind that s is the length of the arc, so it's kind of hard to see with this oblong circle that I drew, but we just have to use our imagination that it's a perfectly round circle and that this is the measure of s, which I can put it there. I can put an s right over here. Okay. So what that means is that basically, if we give you an angle measure, it's always going to tell you what point along the unit circle that happens to be. So, that could be as simple as, like for example, well, you do have to make sure that your calculator is in radians. So like for example, if you type in, like let's say that you're looking at 2 radians. Well, 2 radians tells you that you have cosine of 2, and that's negative 0.42. Versus like, if you look at the sine function at 2 radians, you get 0.91. Now, 2 radians is approximately in the second quadrant, and that's because of the fact that if you were to convert that to degrees, you would multiply by 180, and then you would divide by pi, of which 114. So then in that case, you have that, it's just a matter of just plugging in. So, again, like if theta was equal to 2 radians, then in that case, the ordered pair would be the negative 0.42 comma 0.91, and that's by just plugging it into cosine theta and cosine or sine theta. Okay. Now, in this case, it kind of gives you a little bit of an idea of, okay, well, if we were to look at the unit circle and if we were to pick any angle measure, what does that mean for the domain of the function? Well, notice that if you rotate this angle measure as many times as you would like, you have that basically it's unlimited in that sense. So if that's the case, then that means that the domain for cosine and sine, the domain of that would have to be from negative infinity to infinity. But if you were to look at tangent, that would be a little bit different, because then in that case, you have that tangent is going to be undefined wherever cosine is 0, which in this case would be up here and down here. So that basically means that the domain of tangent and we'll do secant. It's going to be basically such that s cannot equal to integer multiples or odd integer multiples of pi over 2. So n is just an integer in this case. And to clarify, like if it's n equals to 0, it's pi over 2, because that's where that's undefined over here and down over here. And that's the same thing for secant as well. Now, we also have that cotangent and cosecant. So the domain for cosecant and cotangent, well, basically you have that cosecant and cotangent are only undefined at these points, at 1, 0 and negative 1, 0. But to get that, it's basically a straight angle. So that means that s cannot be integer multiples of pi. So that's how it's going to be undefined in this case. Now, one thing that you do have to look at in this section is, in fact, the unit circle. So when we look at the unit circle, you have to realize that you're looking at the unit circle from 0 to 360 first off. But the thing though is that notice that we don't have the ordered pairs, okay? Now, if we don't have the ordered pairs, that's fine, okay? So we already know that basically for every angle measure, you just have to plug in these into the sine, or the cosine, and the sine function. So for example, if I wanted to find the ordered pair as it relates to 0 degrees or 0 radians, then in that case, I know that, cosine of 0, well, that's just going to be 1. But then if I look at sine of 0, that's going to be 0. So that implies that the ordered pair that corresponds to 0 radians, or 0 degrees for that matter, is 1, 0. Now, we can repeat that process by, looking at, say, for example, 30 degrees. Well, similarly, if we look at that, we're going to do the ordered pair cosine theta comma sine theta, which is, I'll work in degrees for this one. Now, cosine of 30, basically you would have to recall your 30-60 triangle, of which in this case you have that 30 degrees is right there. Now, in that case, that gives you root 3 over 2. But then if you look at sine, then looking at sine, you have that that's going to be, well, 1 over 2, which is 1/2. Now, that looks like it's going to be a lot of work when you think about it, because then, we have that that's going to be root 3 divided by 2, comma, 1/2. And see like how you have more to go to fill out? Well, there is a way that we can do this, for instance, like very easily. Okay, my approach to this is that we can think of it in terms of like, let's say that we were to try to look at cosine of theta. Now, let's say that we know that theta in the order is 0 degrees, 30 degrees, 45 degrees, and let's see, 60 degrees, and then we'll do 90 degrees. Now, this method basically requires that we do the following. You have to list out the numbers 4, 3, 2, 1, and then 0. Think of it like your hand, from your thumb to your pinky. You have that basically, you have that 0 degrees is your thumb, you have that 30 is your index, then you have that 45 is your middle finger, and then you have that 60 is your ring finger, and then you have that 90 is your pinky. Now, in this case, like what you'll do is you'll divide by 4 for each of these. Yeah, divide by 4, divide by 4. Now what this does is it tells you that if you take the square root next, that it's going to give you the values of your cosine. So in that case, you have that this is going to be just 4 over 4 is just 1, so root 1 is actually just 1. 30 degrees is just root 3 divided by 2. 45 degrees is going to be root 2 over 2. And then root 1/4 is going to be 1/2, followed by the square root of 0, which is just going to be 0. Now, interestingly enough, if you were to look at, say, for example, the sine function, well, in this case, it's like you're just reversing. Okay, so in this case, for sine, you have that you're going to look at 0, 30, 45 degrees, 60 degrees, and 90 degrees. However, basically, you know that it's going to be the opposite, that you have that it's going to be 0, 1, 2, 3, and 4. Furthermore, what you would do is you would divide everything by 4. So basically the 0 is still acting as your thumb, and then it's up to your pinky, which is the 90 degrees. So what you'll do next is you'll just take the square root, and the square root, and the square root, and the square root. Now what this does is it gives you the following. It tells you that you end up with 0, 1/2, root 2 over 2, and then you have root 3 over 2, and then you have 1. Now, in this case, all that this is doing is it's actually telling me what the ordered pairs are. So the first one is 1, 0. The second is root 3 over 2, comma 1 half, and then it's root 2 over 2, root 2 over 2, 1 half, root 3 over 2, and then 0, comma 1. How that helps me is in the following manner. So note that basically we found 0. So we found that this is going to be 0. Hang on. Let's see. Okay, so let's do it like this. Okay, so let's go ahead and do it like this, where we'll go ahead and say okay, so if we go ahead and we put that, right here we found right here we found 0. So that's 0 degrees, and that's 0 radians. And then we have 1 comma 0. Now this was the 30 degrees, and then this was pi over 6. So we said that that's going to be root 3 over 2, and then we have that that's going to be 1 half. Furthermore, like if we look back at our diagram that we created, like a chart sort of, we're just going to list all these out one by one. So you have 45 degrees, and then you have pi over 4. Then you have root 2 over 2, and then you have root 2 over 2. And then the next one is 60 degrees, and that's going to be pi over 3. So in that case, you have 1 half, and then you have root 3 over 2. Now, basically, it's probably just better to just put, for this quadrant, you have that that's going to be all. So all of them are positive and negative. And then over here, you have 0, comma 1, which in this case, this is 90 degrees, and that's that's pi over 2. This one right over here, you have that this quadrant's going to be S. Now, I'm only going to do the top half, basically. What you can do is probably just, practice in terms of like finding the remaining of the unit circle by using the same method. And I can post this in course documents, and that way you can practice like how do you get this whole unit circle. Okay, now in this case, you have that the next angle measure is going to be 120. Okay, now 120 is basically just a multiple of pi over 3. You can think of it as 2 pi over 3, because you have 120 divided by 60 is 2. So in that case, 2 pi over 3. Okay, now in this case, the reference angle is basically the 60 degrees, because you have that, 180 minus 60, 120 is 60. So in this case, it's the exact same ordered pair, but it has to be negative 1 half, and then you have a square root of 3 over 2. The reason that it's negative 1 half is because only sign is positive. Then furthermore, you have that this is going to be 3 pi over 4. Now the only reason that I knew that was because basically I have that the next angle measure is 45 degrees. So I just took 135 divided by 45, and I got 3, so 3 pi over 4. This is basically the same thing. So you have negative square root of 2 over 2, and then you have square root of 2 over 2. Now the next one is going to be 150. So the reference is going to be 30. So 150 divided by 30 is 5. So 5 pi over 6. So you have 5 pi over 6. And basically that's the same exact numbers. It's root 3 over 2, but negative root 3 over 2. And then you have 1/2. So basically, I only really technically need to know the first quadrant. Then after that, I just need to know the signs. So, and then furthermore, we look at this one over here, which this is pi, and that's 180. Now, in this case, you have that this angle is going to be -1, or this point is going to be -1, 0. So essentially, what you'll need to do is look at the remaining bottom half of the uh, unit circle. So in this case, only tangent is positive, and over here, only cosine is positive. Now, in terms of like the ordered pairs, you're just going to use the same ordered pairs from the first quadrant, and you're just going to either make the components negative or positive. So in this case, they're both negative down over here. So, 7 pi over 6 is 210, but the reference angle is pi over 6, or 30 degrees. So it's the same ordered pair, but negative, negative. Same thing goes for 225 and 240. You have that they're both negative, but what's the reference angle for 225? 45. So it's this ordered pair. And then 240, same thing. Okay. So again, the parameterization of the unit circle is such that the x is equal to cosine and that the y is equal to sine. Okay, now okay, so let's go ahead and do some examples where we want to find a particular value. So let's say that we have sine of 4 pi over 3. And we also want to find cosine of 4 pi over 3. Okay, now 4 pi over 3 is equivalent to, it's equivalent to 240 degrees. So whether you want to convert it or not, you can do whichever. But the main thing though is that you are able to, let's say for example, plot it in the unit circle. So like for example, if you were to draw your radian measure, 240 would be like somewhere over here. So you have, that would be roughly like where 240 would happen to be. So we can probably just do something like this. Okay, now in this case, I noticed that it terminates in the third quadrant, which the only one that's positive is tangent. So I have the ordered pair is cosine 4 pi over 3, comma, sine of 4 pi over 3, and all that we need to do here is just find each of those. So x is equal to cosine of 4 pi over 3, but basically you have that it's going to be negative, so it's going to be negative, but you should also realize that the reference angle is pi over 3. And from there, it's just a matter of knowing cosine of pi over 3. Now cosine of pi over 3 is actually 60, so over here we found that 60 was 1/2, so it's going to be -1/2. Then furthermore, you have similarly that with sine, you have sine of 4 pi over 3, and this is going to be negative sine of pi over 3. But due to the fact that now you're looking at sine of pi over 3, that's sine of 60, which is root 3 over 2. So in this case, I have negative root 3 over 2. Okay, so basically this tells me that the ordered pair, as it relates to that component, is negative 1/2 and then negative root 3 over 2. So a typical question like this is just asking for technically the ordered pair that passes through the angle measure of 240 degrees, or what ordered pair intersects the unit circle. Okay, now of course you could have used your calculator if you wanted to, but in this case, like, you know, if you're using radians, you have to be careful. So like cosine of 4, let me see, cosine, okay, so cosine of 4 pi divided by 3, and if I hit enter, I get negative 1/2, which is the exact same thing. But the only problem is that when you use the calculator for the sine component, it's going to give you an approximation, which is you know, it's okay, but it depends on the question itself. Let's say that, for example, you want to find tangent of 11 pi over 6. Now I'm going to draw this in a way that I don't need to draw the circle necessarily. So 11 pi over 6, it's going to be like this, where you have that pi over 6 is somewhere, 11 pi over 6 is somewhere right there. How I knew that was because if I take another sixth, I get 12, which is 2 pi over 6. So this is our angle measure. Now, in this case, I know that it's going to be negative. So I have that tangent's going to be negative. But let's go ahead and find the reference angle first. So I'm going to take 2 pi minus 11 pi over 6, and I'm going to get pi over 6. So the reference angle is pi over 6. So what this does is it tells me that I have tangent of 11 pi over 6 is equal to negative tangent of pi over 6. Okay, this is where things get a little weird because you have to use tangent pi over 6. So if you kind of either go back here or you have a trusty unit circle, then in that case that's good. So pi over 6 is 30 degrees. So essentially that's just 1/2 divided by root 3 over 2. Now you technically don't have to do it this way, but you can but you can if you want. So you have negative 1/2 divided by root 3 divided by 2, which is equal to negative 1 over root 3. But if you simplify this, that basically gives you that it's just negative root 3 over 3. Now, I will say that, you know, we could have just said, well, once you find the angle measure, like the reference angle, you could have probably just said, well, you have 1 root 3, and then you have pi over 6. So pi over 6 is just 1 over root 3, and then it's negative because it's in the fourth quadrant. So in that case, that's a lot quicker, actually, when you do it like that. Okay, now take a moment to probably try an example. So like, for example, take cotangent of negative pi over 3 and see like what you get. Basically, you know that you're going to need to find the coterminal angle. So we know that to find the coterminal angle, you have to look at theta, and if it's less than 0, that means that you're going to have to add 2 pi to it. But then from there, you would have to say, I need to find the reference angle. Now, technically the reference angle is indicated, but I just want to see like what methods that, or not see, but I just want you to try it out so that you can kind of see that the reference angle is right there. Okay, now the other thing of which that you'll need to look at is approximating trigonometric function values when dealing with radians. So you have that you may be asked to find, for example, sine of 3.42. Now, earlier videos I indicated that whenever the units are not indicated, like it doesn't say radians, it just has a number, it's understood that it's in radians. Which you'll see that like in calculus, whenever like if you see sine 1, sine 2, it's understood that it's in radians. So for these, there's really not much to it other than just plugging it into the calculator. So you take sine, and the value that we were looking at was 3.42, and we just hit enter. Now, basically, that's going to give us an answer of negative 0.2748. So, and you can probably just take 4 decimal places. Usually 4 to 6 is good enough. So that tells me that sine of 3.42 is 0.2748. And I wanted to do the same thing with tangent. But let's see, tangent 0.8234. And then we close it. And you get 1.0790. Okay, so for this one you get, that's not it. 1.0970. Okay, now in this case, one thing that you can try is looking at some of the reciprocal functions. So like, go ahead and try on your own secant of 5.6041, and again, it's understood that those are radians. And then try, for example, like cosecant negative 2.7335. Now, to give you kind of like a hint, if I wanted to use secant, basically I would know that I would need to take 1 divided by cosine. Then I need to plug in my answer. So like, for example, if I did secant of pi over 3, then I would write it like this. And then I would just hit enter, and I would get positive 2. Okay. So yeah, with these approximations, you can't exactly use the triangle necessarily. Now, the other thing of which that we deal with as it relates to the circular functions, so that's the one thing that you have to realize, is that these correspond to some kind of ordered pair along the unit circle. But the other thing of which that we do look at, for example, is like finding the values of s. So like if you have that you want to find what sine of s is, or what is s, when theta is restricted from 0 to pi over 2, that's actually going to be not too bad. But here's where you might run into some trouble. Let's say that you had cotangent of s is equal to negative root 3 over 3, and it was restricted to, this is where it gets a little strange, 3 pi over 2 comma 2 pi. Okay. Now, with the first one, that's actually easy because you can just take that, you're going to take sine inverse of the value, 0.3210, and let's go ahead and just round 4 decimal places, so 0.3268. So again, s is equal to sine inverse of 0.3210, and this is approximately 0.3268. Okay, now similarly, we have that s is going to be equal to cotangent inverse of negative root 3 over 3, which in earlier videos I showed that basically this would be equivalent to tangent inverse of 1 divided by negative root 3 over 3. Now, right now, it's probably best not to, when you have exact values like this, it's probably best to not use the calculator necessarily because it's going to give you a different answer. So only really use the approximation whenever it's restricted to like the first quadrant and you have like that the trigonometric function is equal to some approximated value, because in that case that's easy, just take the inverse using the calculator. But if it's an exact value, that's where it gets a little tricky, and that's mostly because the definitions are not exactly what you think they are. Okay, so the way that we'll do this is that we'll take a look at cotangent of theta equals to negative root 3 over 3. Now, of course, this is equivalent to the statement tangent theta equals to 1 divided by negative root 3 over 3, which is the same thing as negative root 3 over 1. Okay, so it's either or, however way you want to look at this. So my thing is that if I go ahead and I look at tangent, cotangent, and I'm already told that it's in the fourth quadrant, then I already know that basically it looks something like this. Now I'll just draw the ray without the unit circle, and it'll have to be understood that this is somewhere along the unit circle. So there's my angle right there. Okay, so it's somewhere between 3 pi over 2 and 2 pi. So we'll just put that there, 3 pi over 2 and 2 pi. Now, here's where it gets a little tricky. We either need to look at it as negative root 3 over 3, or we need to look at it as tangent of negative root 3 over 1. Now, in that case, I'm going to use the latter because I happen to know that the angle measure that gives me the opposite over adjacent to be root 3 over 1 is when it's pi over 3. So I happen to know that the angle measure that I'm going to get for theta must be 2 pi minus pi over 3, which in this case is going to be 5 pi over 3. So the answer is 5 pi over 3. And that's just because I used that the definition tangent opposite over adjacent, it had to be just that one. Now, if you would have used the calculator, that's where it's definitely not necessarily advisable, because then you'd be doing second tangent 1 divided by negative square root of 3, and all of this is divided by 3, and close, close. So see like how it gives you this number? And if I convert that into degrees, I get negative 60. Now in this case, you would actually go ahead and add uh, the 300 degrees, or 360, because of the fact that you need the coterminal angle. So that gives you 300 degrees. Now this is where you probably may have said, okay, well, if it's 300 degrees, then then that means that that's just going to be converted into radians, which in this case, if you take 300 and you multiply by pi over 180, you end up with 5 pi over 3, which is the exact same thing. So in a way, yeah, maybe we could have used the calculator, but obviously like there's a little more work to it as it relates to being able to find the exact value. What I would say is, go ahead and try. Go ahead and try whenever you have that cosecant of s equals to positive 2/3 root 3, and we'll say that s is somewhere between pi over 2 and pi. So in this case, like, you're going to have to basically kind of reverse the process where you're like, okay, well, 1 over sine of s is equal to 2/3 root 3. But then, if you basically kind of like flip that, it'll give you that not cosecant, but sine of s is equal to 3 divided by 2 root 3, which is equal to root 3 over 2. So that means that you would have to basically figure out what sine inverse of root 3 over 2 is, and then from there have to account for that it has to be in the second quadrant. And that's because it says that. There's no tricks about it. It's like if it says it's in the second, then it's in the second. So that means that, sine is somewhere over here, but we don't know like what angle measure that happens to be. And this is not too bad in terms of like, what would that be? Yeah, it should be probably like 120. But yeah, you should probably go ahead and see if you can do that one. So that way, if you ever see a question like this where they relocate it, then you know how to do it. Okay. Now, mostly the last thing that I want to be able to look at is that that you are okay with as it relates to the unit circle. So, we know all students take calculus. So in any case, like just be sure that you have like your own way of knowing the unit circle. And then, if once we start looking at graphs, then, you can kind of put them together and so on. Um, so yeah, like this is available under course documents in your MyMathLab account, and then there'll be a blank one also for you to kind of work out if you want to fill this out in practice, like how do you get the unit circle. And that's going to come in handy for when you are working on graphs and uh, when you're working on graphs and also like some of the trigonometric equations. Then of course, like if you oops, if you just scroll to this portion, then in this case, like this portion at least gives you the unit circle and the radian measures, which at that point it's just a matter of just figuring out the ordered pairs now. But I made that much more approachable in the aspect of like these are the x's and these are the y's as it relates to the 0, 30, 45, 60, and 90. And again, the way that you do that is that you label your thumb as 0 and then you move all the way to the pinky and then backwards for the other. I will say that basically, like if you know cofunctions, then essentially this is easy too, because if you know cosine of 90, then you know sine of 0. If you know cosine of 30, then you know sine of 60, and so on. So just to finish this off, you just say that, yeah, these are the x's and these are the y's. Okay?